Hello everyone, welcome to our next lesson. Today we are going to learn about two more trigonometric ratios called the sine and cosine ratios. In the previous lesson we learned about the tangent ratio, which is a ratio of the lengths of the legs of the right triangle. The sine and cosine ratios are a ratio that involves the length of a leg of the triangle and the hypotenuse of the right triangle. Specifically, this is how we define the sine and cosine of an acute angle of a right triangle. If angle A is an acute angle, then sine of A will be equal to the length of the leg opposite of angle A over the length of the hypotenuse. Cosine of A is going to be the length of the leg adjacent to angle A over the length of the hypotenuse. And again, the leg that's adjacent is the leg that's next to the angle, that's not the hypotenuse. So let's find the sine and cosine values for the two acute angles of this triangle right here, ABC. Sine of angle A is going to be opposite over the hypotenuse. So opposite is BC over AB, the hypotenuse. Cosine of angle A is going to be the ratio of the leg that's adjacent or next to angle A, which is AC, over the hypotenuse, AB. We can also find the sine and cosine values of the other acute angle of the right triangle, angle B. Sine of angle B is going to be the opposite over hypotenuse, so AC over AB. Cosine of angle B is going to be the leg that's adjacent to angle B or next to it, BC, over the hypotenuse, AB. And there's something interesting that happens here with the sine and cosine values of the acute angles. Notice that the sine of angle A has the same ratio as the cosine of angle B. Same thing's true for the cosine of angle A. It has the same ratio as the sine of angle B. We're going to talk about this after we finish example 1. Now we've just learned three trigonometric ratios that are frankly three different fractions. We use this mnemonic right here, Sohcahtoa, to remember the trigonometric ratios. The so right here means sine is equal to opposite over hypotenuse. So represents sine is equal to opposite over hypotenuse. Ka is going to be cosine is equal to adjacent over hypotenuse. And lastly, toa, we use this for tangent. Tangent's equal to opposite over adjacent. So this mnemonic Sohcahtoa, this is probably the most important thing to remember in this chapter. Now we're going to find the sine and cosine ratios for some right triangles. In example 1, we are going to find the sine and cosine ratios for the acute angles of the right triangle. We're going to write each answer as a fraction and then as a decimal rounded to 4 places. I'm just going to start off with angle R, so let's find the sine of angle R. Sine is opposite over hypotenuse, so the side that's opposite angle R is ST, which has a measurement of 16, and the hypotenuse is 65. This gives us 16 over 65. Let's do the cosine. Cosine of angle R is going to be the adjacent over the hypotenuse, so we are going to get 63 over 65. Now let's find sine and cosine for angle S. And again, I forgot to mention that when you're writing your sine and cosine, make sure that you write the angle, either the vertex of the angle or the angle measurement of the angle. Again, we can't have just sine is equal to a fraction. It doesn't make sense if there's no angle that it's referring to. Now for sine of angle S, sine is always opposite over hypotenuse. So opposite 63, hypotenuse is 65. This is going to give us 63 over 65. And cosine is adjacent over hypotenuse. So adjacent of angle S is 16 divided by the hypotenuse 65. So here are our trigonometric ratios in fraction form. Now let's just put this into our calculator. And I get 0.2462 for 16 over 65 and 0.9692 for 63 over 65. Let's do this one more time. All right, so again, we are going to find the sine and cosine values for the acute angles. I'm going to start off with angle F. Sine of angle F is going to be opposite over hypotenuse. This gives me 24 over 25, which is equal to 0.96 in decimal form. Cosine of angle F is going to be adjacent over hypotenuse, so I get 7 over 25. And that's 0.28 in decimal form. Now let's find the sine and cosine values of angle D. The sine of angle D is going to be opposite over hypotenuse. That gives you 7 over 25, which is 0.28 in decimal form. Cosine of angle D is going to be adjacent over hypotenuse. You get 24 over 25, which is 0.96 in decimal form. I'll let you guys try C, and let's move on to our next concept. So we noticed that for the acute angles of the right triangle, the sine and cosine values will switch. So we see that over here. Sine of angle F and cosine of angle D have the same ratio. Likewise, cosine of angle F and sine of angle D, it also has the same value. And the reason that occurs is because those two angles are complementary, they add up to 90. So we sum that up with this rule called the sine and cosine of complementary angles. The sine of an acute angle is going to be equal to the cosine of its complement. The cosine of an acute angle is equal to the sine of its complement. If A and B are complementary angles, then these following statements are true. Sine of A is going to be cosine of 90 minus your angle A, and that's going to give you cosine of B. Cosine of A is equal to sine 90 minus A. This will give you sine of B. So essentially all you're doing is you're going to take that angle measure and you're going to subtract 90 and that number and then just change from sine to cosine or cosine to sine. And that's all you got to do. So let's do example 2. We are going to be rewriting the trigonometric expressions using this rule. For A, we are asked to write sine 56 in terms of cosine. So since we're starting with sine, we're going to switch to cosine. And then we just want to do 90 minus 56. And this is going to give you cosine of 34. Let's do this one more time. We're going to write cosine of 23 in terms of sine. So we want to switch from cosine to sine. And then we want to do 90 minus our angle. This is going to give you sine of 67. We're going to do one more example today. In example 3, we're going to find the missing measurements of the triangle. And we're going to find the values of the variables using sine or cosine. And we want to round our answers to the nearest tenth. So for A, we know that this angle here has a measurement of 26. We don't know the lengths of the legs of the triangle, but we do know that the hypotenuse is 14. So let's start off by finding x. If we know this angle and we know the hypotenuse, we need to decide whether we're going to use sine or cosine. You want to use sine if you're looking for the opposite or the hypotenuse, and you want to use cosine if you're looking for the adjacent or the hypotenuse. So since x is opposite of our angle 26, we're going to use sine. So sine of 26 will be equal to opposite over hypotenuse. And then from here, we just need to cross multiply. And then we want to put this into our calculator. So you want to press the button that says sine on your calculator. And then you want to put in the angle measurement. In this case, it's 26. And I get 6.1 since we're rounding to the nearest. Now let's find y. So if we're using this angle that has a measurement of 26 and we're looking for y is adjacent to this angle. And we also know the hypotenuse, so let's use cosine. And this gives me an equation of cosine of 26 is equal to y over 14. We want to do the same thing. We can cross multiply. And then we want to put this into our calculator. You want to find the button on your calculator that says cosine, and then you type in the angle measurement. And this gives me 12.6. Something else that you could do is you can find the measurement of this angle and you could do the same thing. Your answers are still going to be the same. Let's do B. For B, we know that this angle has a measurement of 65 and the hypotenuse has a measurement of 8. If I am looking for T, I want to use sine because T is the opposite of angle 65. So this gives me a equation of sine of 65 is equal to T over 8. And then we need to put this into our calculator. This rounds to 7.3. Now let's look for U. U is adjacent to angle 65, so we're going to use cosine. And this gives me an equation of cosine of 65 is equal to U over 8. We'll cross multiply. And then let's put this into our calculator. This rounds to 3.4. Now that's it for our lesson for today. Please let me know if you have any questions. I hope you have a wonderful day and take care.